We had a request to do some multiple choice questions from Fall 21 Test 2. I think we chose the right screen. I hope so. Somebody tell me if we don't see questions 12, 13, and 14 before I move on. Fall 21 Test 2 Part 1. And we're supposed to do some functional groups. All right. So here's the functional group. And that's a secondary amide. I never look at the answers to these questions. But the secondary amide is in a ring. It's a lactam. And I don't see any primary, secondary, or tertiary at all, so I'm going to stop saying it's secondary. That's not relevant for these answers. And in blue, we have an imide. Yes, that's a nitrogen attached to 2 carbonyls. And down here is an ester. That's not in a ring, so you can't call it a lactone. And then we have the last one has carbonyl with O's in it. O's attached. That's 2 carboxylic acids linked together with water missing. You guessed it, it's called an anhydride. So putting them in order, the first one is 1, needs to be an imide. So imide. 1 is an imide. 2 is an ester, which has name that's green. It's 1. And the third one, baby blue, is an anhydride, which is IV. And 4 is an lactam in red, and that's B. So 2, 1, 4, 5. Finding the answer is always fun. There it is. 2, 1, 4, 5. And there you have it. Next one's a pKa, next 2. You'll have 2 that are linked like this. And we might as well write hydrogen down because you're going to need its pKa. Don't write down the pKa of 5-methyl-4-oxo-6-hexanolactone until you write the structure down. So hexanolactone attached to position 6. So here is position 1, carbonyl. Here's position 2, 3, 4, 5, 6 is attached to an O right there. Just a reminder, 1, 2, 3, 4, 5. All right. I don't think I counted right. 1, 2, 3. Well, sorry. This is carbon 1. I had alpha beta mixed up with the numbering system. Can't do that. 1, 2, 3, 4, 5, 6. In all fairness, go back in the video, and when I said 1, I said carbonyl, and then I didn't write it down like that. Okay. And there's that. And there's a methyl on 5. There's an oxo on 4. Okay. You want all your possible pKa's? Good review. Alpha to a ketone here or here. Those are both alpha to ketones. pKa 20. Alpha to an ester, 25. Do not pick that one. It is not the most acidic H. It is incorrect to pick the blue H. Don't do it. Most stable resonance form for product question mark. Well, If you take the H from here, you're going to make an enolate that goes this direction with a double bond that has the methyl on it. If you make an enolate here, you make a double bond that doesn't have a methyl here. It has an H instead. There's another H here I want to point out. And the more substituted one's going to win. So I like the one where the double bond is between the carbonyl carbon and the methyl carbon. Carbonyl carbon and methyl carbon. Carbonyl carbon and methyl carbon. And why is there no carbonyl? Because it resonated. That's why. Please don't pick any resonance form where the potassium's on a carbon like this. Don't. That will never be the most stable resonance form. This thing can't even resonate with anything. It's a terrible choice. This was, I don't know what that was. It's weird. Oh yeah, that was the ester. Don't pick the ester. 25. What about this one? This is just goofy. It said there was an alcohol here. There's no alcohol in this molecule. Where's the one with the double bond towards the methyl? It's this one. And there'd be a CH2, 6. You're having trouble? You need the numbers? Here they are. 6, 5, 4, 3, 2, 1. That's our guide. pKa 20, more substituted double bond, has both. And what's closest to pKeq? Well, that's a 20 minus 25, 35 situation. And that's not KEQ, that's pKeq. That's the one we get to first. KEQ equals 10 to the positive 15. Flip the sign. AB. And a quick finish to our video here. We're going to do number 15 as well. Diethyl adipate. So it's diethyl adipate with 4 extra carboxylic acids on positions 2, 3, 3, 4. And ladies and gentlemen, I hope I made it clear. If you don't know the dicarboxylic acids, you're going to be costing yourself a lot of points. In summary, oh my, such good apple pie. This is for 2 carbons. 2, 3, 4, 5, 6, 7. Why did I not start at 1 carbon? Because you can't have a dicarboxylic acid with 1 carbon. That's why. So we're looking for adipate. 6 carbon dicarboxylic acid. Carbon 1, 2, 3, 4, 5, 6. Position 2, 3, 1, 2, 3. There's a carboxylic acid here. There's two more here. And 1 more here. Are there any carboxylic acids beta to another carbonyl? If so, it will disappear upon heating. And let's just talk about this first carboxylic acid. Is it beta to another carbonyl? Answer, yes. Here's the alpha position. Here's the carbonyl of another carboxylic acid. Goes away. This hasn't gone away. This won't go away. New question, is this beta to another carboxylic acid's carbonyl? Answer, no. For this carbon, there's alpha, there's beta, there is no carbonyl on the beta position. This one stays. New. This is a carboxylic acid. Here's the alpha position to that carboxylic acid. There's another carbonyl beta. This carboxylic acid will disappear. Okay, what you're left with is what's not crossed off. Is this carboxylic acid still beta to another carboxylic acid? Answer, no. Alpha position to this I'm not even going to write letters down for this one. Alpha is here. Beta is here. That is not a carbonyl. Beta could have also been here. That is not a carbonyl. This one stays. Is this carboxylic acid beta to another carbonyl? There's alpha, there's beta, not carbonyl. There's alpha, there's beta, not carbonyl. This one stays. Is this carboxylic acid beta to another carbonyl? Answer, no. There's alpha, there's beta. It's not a carbonyl. Copy out what you've got left. All right, it's a little messy. One, two, three, four, five, six. So it's still adipic acid. Still adipic acid because it still has a 6-carbon chain with carboxylics on each end. It's got carboxylics on 3 and 4. So, oh, diethyl adipates. It doesn't change my answer. I just didn't read my question right. And you guys are very polite for not pointing anything out. This one should not have been crossed off because it wasn't a carboxylic acid. Sorry if this is confusion for you. It was an ester. No big deal. No big deal. Won't be crossing that off. But this carboxylic acid here is beta to this carbonyl. So this check mark's going to become an X. I'm glad I made the mistake. It made it 2 questions for the price of 1. So what happens now? This carboxylic acid is beta to this. Let me prove it to you. There's the carboxylic acid right there. There's the alpha position. The beta position is a carbonyl. This thing is going to disappear. Bye-bye. The ester did not disappear because you don't do decarboxylation of anything except for carboxylic acids. And remember, I made that mistake and I got to fix it both places. We didn't lose that, whether it was an ester or a carboxylic. There we go. That's your molecule. And what are we going to say? It's a diethyl adipate still. How many carboxylic acids? This is the new carbon 1. There's one on, there's not one on 2. There's one on 3 and 4, whether you count it this direction or the other direction. 1, 2, 3. It's symmetrical, isn't it? 3,4 dicarboxylic acid. And that would be choice diethyl adipate 3,4. Diethyl adipate 3,4. We have a winner. Okay. And I think that concludes things. We had a discussion before this video that we all agreed it didn't really need a video, but interesting stuff. I think maybe I erased it. Maybe it's on the page before this one. Maybe not. Interesting. Oh well. Maybe it's underneath. It's on top. There it is. We had a question where we asked how to draw and name a mixed anhydride. We did 2 examples. They're here. I will leave this here for you to use in your studying. And I'll come back and see if we have any questions after this.